Hi, I'm Ms. Cho, and in this video, we'll learn how to write and solve systems of inequalities word problems. Our word problem strategy is PACE. The first part is preview. What is the question asking? The second part is annotate. What is the important information? The third part is compute. This is where we do the math. And finally, the last part is examine, where we check and see if our answer is reasonable. The steps I'm about to show you are an extension of how to annotate for word problems with systems of inequalities. In this example, a theater wants to make at least $2,000 from one show. Children's tickets cost $5 each and adult tickets cost $10 each. The theater has a maximum of 350 seats. What is one possible combination of ticket sales that would meet these requirements? The first part of PACE is the P. What is the question asking? And it's this last part. What is one possible combination of ticket sales that would meet these requirements? So that tells me that there could be multiple solutions and there's not necessarily one right one. The second part is to annotate. Here, we're going to annotate a little more specifically. What are the variables? What are the things we don't know? I see that we have children's tickets that cost $5 and we have adult tickets that cost $10. But we don't know how many tickets we have, so I'm going to let C be the number of children's tickets and A be the number of adults tickets. The second part is to answer the question, what are the constraints, conditions, or limitations? These are the parts of the problem that have keywords like at most, at least, minimum, and maximum to indicate there's some sort of inequality happening here. As I look through the problem, I see two constraints. I see one is that the theater wants to make at least $2,000, so money is a constraint. And the second constraint I see is that the theater has a maximum of 350 seats. Since every child and every adult has to sit down, that tells me that there's a limit to the number of seats or number of tickets we can sell. Now that I have my variables and constraints, I can write a system of inequality just to describe the problem. I need one inequality for every constraint that's in the problem. So the first one is money. I know that I need to make at least $2,000, and at least tells me it's greater than or equal to. How do I get that? It's by selling children's tickets and adult tickets. And I also know that children's tickets cost $5 each and adult tickets cost $10 each. So $5 times the number of children's tickets plus 10 times the number of adult tickets should be at least $2,000. The second constraint is that we have a maximum number of seats. So the number of tickets has to be less than or equal to 350. And since every child and every adult takes up one seat, C plus A is less than or equal to 350. My next step is to graph the system and list at least one possible solution. In order to do that, I'm going to rewrite this as x's and y's. So I'm going to let x be the number of children's seats and y be the number of adult seats. Plugging this in gives me 5x plus 10y is greater than or equal to 2,000. And then my second equation is x plus y is less than or equal to 350. Now, if I were using this on a graphing calculator, I would have to solve everything for y equals, but since I'm going to use Desmos, I can plug it in just as is in standard form. In Desmos, I've placed both my inequalities that I've written, and I see that I have this overlapping region in purple here. This means that any point in the purple overlapping region or along the solid border lines is a solution. So I'm going to choose this one here, which I think is 100, 200. I'm going to plot that. And it falls solidly within the purple area, so I know that this is a potential solution. We chose the point 100, 200, but what does that mean? Remember, we said that x was C, so my x, y, the number of children's tickets, and then my y is equal to A. So then this tells me that I have 100 children's tickets and 200 adults tickets. And now I need to plug in this point into both my inequalities to make sure that both statements are true. I'm going to fast forward through this part. Since both my inequalities are true, when I sell 100 children's tickets and 200 adults tickets, I know that that is one solution. Let's summarize. When we have a system of inequalities word problems, we want to use a PACE strategy. Within that, we define our variables, we list our constraints, our conditions, or our limitations. We write the system with one inequality for every constraint. Then we graph the system and find one potential solution. This solution has to be in the overlapping shaded region or on a solid border, not a dotted border. And lastly, we verify algebraically that the point that we chose is the solution by making sure that it makes all the inequalities true.